Okay, earlier we were discussing, we've covered addition, subtraction, and multiplication of polynomials. And yesterday, I believe we began to look at division, and we discussed the fact that there were two methods of dividing polynomials. We looked at the long division method first, and as you've probably seen by now, that can be a little tedious at times. It's not necessarily the easiest thing to do because there's so many different things that you have to keep straight and so many steps. Today we're going to look at a method that we can use from time to time in certain occasions called synthetic division, which is a little bit easier and is a little bit more simplified approach to doing this, but it only works in certain scenarios, so we'll discuss that as well. So the other method, as we said, is called synthetic division. Synthetic division involves multiplying and adding. It doesn't involve, long division has the steps, we divide, then we multiply, then we subtract, then we bring down the next, and we just keep repeating that. With synthetic division, all we're going to do is multiply and then add. Multiply and then add, and we just keep doing that until we reach the end of the problem. It's often a lot quicker, but it can only be used when we're dividing by a binomial term. That means something with two terms in it. We'll double check what that means in just a second. I'll show you exactly what I'm talking about. But you can only use this in certain scenarios. We can't use it in longer cases. Now what we're going to do right here is we'll look at an example. If you remember, we actually did this example yesterday with the long division method. But you can see we're dividing by x minus 2, and that is a binomial. So that allows us to use what we call the synthetic division method. Now when we do this, we're going to take that x minus 2 and we're going to identify the value of x that would make x minus 2 equal to 0. Well, if we stop and think for a minute, what could I plug in for x to make x minus 2 equal 0? That would have to be a positive 2. And once we've identified that, we're going to take it and stick it over here, and we're going to actually draw a little half box around it and separate it from the rest of the problem. Once we do that, we're going to list off the coefficients of the dividend. Now the dividend is the 3x to the third plus 4x squared plus 10. That's the thing that we're dividing. And we're going to list off the coefficients. Now the coefficients are the terms or the numbers in front of the term, each term. We've used that term before, so make sure you're clear on what we mean when we say coefficients. For example, for 3x to the third, the coefficient is 3. So we're going to list that off. For 4x squared, the coefficient is 4. Now, I'm just going to list these numbers off. Notice, though, that we are missing an x to the first power, so we're going to have to put in a 0 to represent that spot that doesn't have the x to the first. You'll remember we did this yesterday with long division as well. And then we're going to put the 10 in there. Once we do that, we're just going to draw a little line. We're going to leave a space there, and we're going to draw a line underneath. After we do that, we're pretty much ready to go, and we'll begin by bringing down the first number. Now, the first number is 3, so we're just going to drop it straight down below that line and use that as the start of the problem. And again, we're going to multiply and add. There's no division actually involved with synthetic division, which makes it kind of cool. But we're going to say 2 times 3, 2 being the 2 in the box, and 3 being the number down there at the bottom. We're going to multiply 2 times 3, which of course is 6, and we're going to put that number right here to fill in that blank area there. Now, once we've done that, we're ready for the next step. Instead of bringing down 4, we're just going to add 4 plus 6. 4 plus 6, of course, is 10. Once we do that, we just repeat the process. We take the 2 in the box, we multiply it by the 10 down here at the bottom. 2 times 10 is 20, and we put that 20 right here. We add again, so we add 0 plus 20, and of course that's 20. And once we do that, we're going to multiply 2 times 20. 2 times 20 is 40, and we have 10 plus 40 to add. You'll notice all we did was multiply 2 times whatever number was on the bottom, and we got the number to put into the next spot to add. And we just continuously did that till we get to the end. Now you'll see that 50, that last number, is always going to be my remainder. And you can't really see that at the bottom of the screen, but that says the last number is always your remainder. So when we write out our answer, we're going to begin with the 3, and we're going to make that the coefficient of our first term. Our first term will be 1 degree lower than what we started with. We started with 3x to the third, so if we're going to drop that down 1 degree, we'll have 3x to the second plus 10x, which would be the next lowest degree, and then 20, which would be a degree of 0, no x there, and then we'll list our remainder, 50 over x minus 2. Once we've got that, we're completed. That's our answer. 3x squared plus 10x plus 20 plus 50 over x minus 2. And that is synthetic division in a nutshell. Now, real quickly, what we're going to do here now is go through a couple more examples I'd like to show you. You can see we've got a problem here. 3x to the fourth minus x to the third plus 5x minus 1. We're going to divide that by x plus 2. So again, we'll take this divisor and identify the value that would make that equal to 0. And of course, that would be negative 2 this time. So we're going to take negative 2 and put it in our box, and then we're going to list off our coefficients. And you can see we're missing an x squared. There isn't one. So we're going to have to fill in something to take the place of that value. We'll use 0, of course. So we list off our coefficients. We've got 3 for the x to the fourth. We've got negative 1, which comes right here from our negative x to the third. We're going to put in a 0 for our x squared term. And then we're going to list off 5 and negative 1. Put in our line. And then we just begin by dropping that first number down. Coincidentally, it's a 3 again. So we just bring the 3 down, and then we multiply. Negative 2 times 3 is negative 6. Okay, now we're going to take that negative 1 and negative 6, we add those, we get negative 7. And then we multiply again. Negative 2 times negative 7 is 14. 14 plus 0 is 14 again. And then we say negative 2 times 14, which is negative 28. Excuse me, I'm getting my colors mixed up. And we say negative 28. 5 plus negative 28 is negative 23. And we're getting a big number, but that's fine. Now we'll say negative 2, again, times negative 23 is going to give us positive 46. And we add, for our last term there, negative 1 plus 46 is 45. This is our remainder. That's the last term, the last number is always the remainder. And then we'll write out our answer. We'll begin with 1 power, 1 degree, less than that x to the fourth, so that would be x to the third. And then we just take the coefficients. 3x to the third, we drop down 1 power, and we have 7, or minus 7, x to the second, plus 14x, minus 23, plus 45, over whatever we were dividing by, which was x plus 2. And that is our answer. Now hopefully this is still running. Okay, and now we can continue with this other example here. And you'll see this example is a little bit less complicated, but we can still follow the same process that we followed in the first one. I'm going to take my divisor, which is x plus 1. Whoa. X plus 1. I want to dance around for me. All right, x plus 1, and we're going to say what would make that equal to 0. What value of x would make that equal 0? Well, again, that would be negative 1. So we're going to write that down, set it to the side in this little box, and then we're going to list our coefficients. Or in this case, we have 4, we have 5, we have 1. We're not missing any x's. We have x to the second, x to the first, and then no x. So we can just fill in those numbers, 4, 5, and 1. Notice again, I don't have to use a 0 here because I'm not missing anything. So again, we'll start the process by dropping down our first number, which is the 4. So we drop that 4 down, and then we multiply. Negative 1 times 4 is negative 4. And then we follow the next step, which would be to add, multiply, and then add. 5 times negative 4 would be 1. And then we have negative 1 again times 1, which is negative 1. Excuse me. Negative 1. All right, and then we add that, and you'll notice what happens is we actually get a 0 here. So that 0 is our remainder, which means we don't have a remainder. That's not a bad thing. That's actually good. So we'll start off with 1 degree less than we had right here, and that would be x to the first. So we have 4 x to the first plus 1. That is our answer. There's no remainder, so we just leave it off, and we just finish that problem up. So as you can see, synthetic division is quite a bit simpler than following the long division process. Now, long division, of course, is a method that will work with every problem. In the case of synthetic division, it works best when you just have a simple divisor, a simple binomial divisor, like x plus 1 here, or x minus 5, or something along those lines. Now, if you have something like 3x plus 5, or something along those lines, long division is a much easier method. It gets really complicated to do that with synthetic division, and we're not even going to try that in this class. So there is synthetic division in a nutshell.